Alright, this is the part 1 of lesson 2 on graphing quadratics, and we're going to start with just looking at how parabolas get translated. So the first thing we have to understand is what a parent function is, and a parent function is the simplest equation in a family that still contains the characteristics of that family. Since we're talking about quadratic equations, and these all have the form y equals ax squared plus bx plus c, or quadratic functions, because we've got the y in there. The simplest one that still has everything it needs, and by everything it needs to have the quadratic portion, so it has to have a x squared in it. So if b equals 0 and c equals 0, and we let a equal 1, we get this equation right there, y equals x squared. And that's as simple a quadratic equation as we can get. So we call that that's pretty much the parent function for all quadratics. It gives you a parabola when you graph it, and because it is the parent function for all quadratics, we better know how to graph that thing by hand. So whenever you want to graph an equation, you can always brute force it and just start graphing points and look for a pattern in it. For example, when I plug in a 0 and square it, I get 0. 1 gives me 1 when I square it, 2 gives me 4 when I square it, and 3 gives me 9. I haven't done any fractions, but negative 1 squared gives me 1, negative 2 squared gives me 4, and negative 3 squared gives me 9. So we're starting to see a little symmetry, like 3 gives me 9, and negative 3 gives me 9. So let's graph these points. Okay, so we've got 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Let's go ahead and do the 3, 9, and the negative 3, 9. We can see they all had a symmetric point. In fact, I'm going to go ahead and draw in the axis of symmetry. Except for 0. 0 goes right through that axis of symmetry, so what's the vertex? And so the parabola, simplest, most basic parabola, looks like that. Notice x, the domain, is all real numbers. That means I could have plugged in 10 for x if I wanted to, and I'd get 100 out. So this thing keeps getting wider and wider as you plug in bigger and bigger x's, and continues to go upward. Okay, so there's our basic parabola, y equals x squared. And one of the things we often do is like to compare that to other parabolas, or rather compare them to it. So on this next slide, I've got our basic parabola drawn again, y equals x squared, and we're going to graph the purple one, y equals x squared plus 2. Okay, so I'm going to blow this up. We talked a little bit about this in class. In fact, you had a homework assignment on it, and we decided that this plus 2 here shifts our parabola up by 2 units. So if we think about the point on the parent function again, this is x, and this is what x squared gives us. That's our 0, 0, 1, 1, 2, 4. If we were doing x plus 2, it would give us 0 would give us 2, the 1 would give us 3, and the 4 would give us 6. Guess I better add 2 better. Okay, so it takes every single x value and or every single function value and adds 2 to it. So when I graph this one, just do it in purple to match it, sliding up by 2, instead of 0, 0, I get 0, 2. Instead of getting 1, 1, I get 1, 3. Instead of getting 2, 4, I get 2, 6. Every point slid up by 2 units. See if I can get my symmetry right here. Right there, and right there. And so there is x squared plus 2. Okay. Now, likewise, again, I'm going to make this table here. This time I'll make it so we can see it. Okay, this time I'm going to do the parent function, 0, 0, 1, 1, 2 gives me 4. This time I'm going to let x plus 2 generate my points. When I plug in a 0, I get a 4. 0 plus 2 is 2, 2 squared is 4. When I plug in a 1, I get a 9. When I plug in a 2, I get a 16. I'm going to plug in some other x values because 216 seems pretty hard to graph. Okay. I'll plug in, instead of 0, I'll plug in negative 1, which gives me negative 1 plus 2 is 1, squared is 1. Now I'll plug in negative 2, that gives me 0. If you recall from what we looked at in class, this function was slid left by 2 units. You can see that negative 2 now acts like the 0 for it, right there. And then negative 1 gave me 1, and 0 gave me 4. And once again, I can sketch in my parabola. Okay. So now, in being descriptive, we can explain what these do. So this is our parent function, and the purple one we would say is shifted up by 2 units, and the light blue one we would say is shifted left by 2 units. And the last thing we'll look at is what the value of a does. A is, remember, these functions are all ax squared plus bx plus c. And so a is the value right in front of the x squared, so in this case 3, and in the last case a half. So I'm going to generate some points for the purple graph. Y equals 3x squared. Okay, so here's my x and y values. Notice I get 0, 0 again. I plug in 1. This time I square 1 and then multiply times 3, so it gives me 3. Then I square 2 and I get out a 12. Negative 1 gives me 3. Negative 2 gives me 12 also. So let's graph these guys. There's 0, 0. Here is 1, 3. And here is 2, 10, 11, 12, way up there, if I can get it in. Okay, I'm going to let symmetry give me a couple other points. Right there. And so look what the value 3 did to my parabola. Okay, and this is always true when this a value is bigger than 1. If a, I guess I should say the absolute value of a is bigger than 1, the graph gets narrower. And we can see that. There's my parent function in orange, y equals x squared. And when I put a 3 for the a value, it did make it narrower. If I'd put a 4 in there, it had stretched it and elongated it and even made it more narrow. Let's do the same thing now with, let's write that in a different color, the half x squared. We'll use light blue again, y equals 1/2 x squared. We'll generate a few points for this thing. 0 gives me 0 once more. 1 this time only gives me a half. 2, I square it and get 4, and then half of 4 is 2. 3, I square it and get 9, and half of 9 is 4.5. 4, if I square it, I get 16, and I get an 8. So 0 gave me 0. 1 only gave me a half. 2 only gave me 2. 3 gave me 4.5. And 4 gave me 8. Okay, so notice what that did. Now again, remember we're comparing it to the parent function, the orange function. What did it do? It clearly made it wider. Okay? And this always works when a, the absolute value of a, is a fraction. If it's between 0 and 1, it will be a wider parabola. Now you notice I said these things about the absolute value, and the reason I did that is because it doesn't, whether a is negative or positive does not affect its width or how narrow it is. Instead, negative signs are what control it in terms of which way it opens. So had this been y equals negative a half x squared, the a value of a half would make it exactly the same width as that blue one. However, it would have, instead of the black one being right side up, it would actually have been facing downward. Okay, so the negative sign controls it up and down. Okay, so I'm going to kind of summarize this and show you how you can use this to answer questions. So for example, let's say I've got y equals 3, let's not use 3, let's use negative 4x squared. And the question is, how does this compare to the parent function? Parent function being y equals x squared. I'd say this new parabola is going to be narrower because of the 4 and opens downward. Okay, the negative sign makes it open down. So hopefully you kind of understand. We can make it really complicated. Let's look at a really complicated one. Y equals negative 1/2 x minus 3 squared plus 2. Okay, let's break this down a little bit. This will shift it right 3 units. The 2 will shift it up 2 units. And the half, oops, let's use a different color to be consistent here. The half will make it wider than the parent function, and the negative sign will make it open downward. That's about how we would describe it. We'd say this parabola opens down, it's wider than the parent function, and shifted right by 3 and up by 2 units. Hopefully that helps. There will be a second part, and you do have homework on this. It's part 1 homework, and you don't have to graph it on the homework. In part 1, it asks you to just describe how it is translated from the parent function, and so you're just going to use descriptive statements like I've used on this slide to state how the new parabola would be translated or transformed.